We shall now look at Newton's second law. While the first law states what happens if the resultant force on the body is zero, meaning that there will be no acceleration, the second law simply states that if there is a net force acting on the body, then there will be an acceleration. Furthermore, the size of the acceleration is found by the equation F net equals mass times A. This can also be written as acceleration A equals F net divided by mass. Let's see what Newton's second law predicts when the forces acting on a body are balanced. Then the net force is zero. Substituting into the equation, we see that if the net force is zero, the acceleration will also be zero. So in this way, it actually overlaps with Newton's first law. It states that the body will remain in a state of motion or unaccelerated state. However, what happens when the net forces exist? When the forces acting on the body are not balanced? In this case here, the normal reaction force is smaller than the F gravitational force. That means that there is a net downward force. According to Newton's law, which states that if there is a net force, then there will be an acceleration. Furthermore, the acceleration will be in the direction of the net force. Looking at the body here, the net force is downwards, therefore the acceleration is downwards. The acceleration can be found by the net force divided by the mass. Let us put some values into our forces. Let's say that the physics book was 5 kilograms. That would mean that it has a weight or gravitational force of 50 newtons. And let's say that the reaction force, or the normal force, was 20 newtons. That means that there is a net downward force of 30 newtons. So that net force of 30 newtons will cause the 5 kilogram mass to accelerate downwards. Let's put things into the equation. The acceleration can be found by the net force divided by the mass. The net force is the 50 newtons downwards minus the 20 newtons normal force divided by the mass of 5 kilograms. That gives us an acceleration of 6 meters per second squared. In the case that the normal force was reduced to 30 newtons, we need to relook at the whole situation again. So we look at the body isolated from its surroundings. We draw a free body force diagram showing the forces acting on it. And we look at what the size of these forces are. 50 newtons acting downwards, 30 newtons acting upwards. That means that there is a net force of 20 newtons downwards. Newton's second law states that since there is a net force, there is an acceleration, which can be found by using the equation F net over mass. The net force in this case is 50 minus the normal force, which is 30 newtons, divided by the mass of 5 kilograms, now gives us an acceleration of 4 meters per second squared. This is basically Newton's second law. It states that if there is a net force acting on a body, then there is an acceleration in the direction of the net force, and the value of the acceleration can be found by dividing the net force with its mass. Remember that acceleration has units of meters per second squared.